Hi everyone, this is Suresh Babu, Controller of Examination, Sri Shanmugha College of Engineering Technology. So today we'll be discussing about the addressing modes of 8086. What is meant by addressing mode? Why it is needed? That's the first question, right? So when we work with a microprocessor, the data will be stored in either it may be stored in any memory locations, or it may be stored in some registers, or directly uh, directly the data can be given to the processor. So it is necessary to know where the data is present, then only you can access the data. So based on the accessing technology or methodology, the execution time may differ. So it is necessary to utilize appropriate addressing modes to address the data. So our 8086 microprocessor supports 9 different types of addressing modes, namely immediate addressing, register addressing, direct addressing, register indirect, index addressing, based and indexed, based and indexed with some displacement, and finally string addressing. So one by one we can look how it works. So the first one is immediate addressing mode. In immediate addressing mode, an 8-bit or 16-bit data can be directly given in the instruction. So as the data is directly given, it is called as immediate addressing mode. So you can see the example that move AX, 10 ABH. The H represents the hexadecimal value, and since the data is directly given, this comes under immediate addressing. So after execution of move AX, 10AB, the lower 8-bit of data, that is AB, will be get stored in AL register, and 10 will get stored in AH register. The second one is register addressing mode. In register addressing mode, we will be using one of the register to hold the data. So here we have given an example, move AX, BL, which means the data is stored in BL register. So the data from the BL register will be get stored in AL register. The next one is direct addressing mode. Here the address where the data has been stored will be directly specified in the instruction. Thereby it is called as direct addressing mode. So here you can see the difference between immediate and direct addressing. In immediate also we have directly specified some numbers, but there we doesn't use a square bracket. So if anything comes within a square bracket, you can assume that the value specified inside the bracket refers an address location, not a data. Clear? Here the mnemonic is move AH, memory address. An example, AH bracket 1000. So 100 is the offset address where the data is present. Actually the data will present in data segment register. As you all know, we have 4 different memory segments: data segment, code segment, stack segment, as well as extra segment. Normally we'll store data in data segment and extra segment. In general operations, the data will be taken from data segment. Here the 1000 represents the offset address from where the data is stored from the base address of data segment. The next one is register indirect. Here we utilize a register to find out the memory location. So memory address, that is you can see that address move AX, SI. Since SI is specified inside a square bracket, now the content of SI represents a memory location, that is the offset address of the data where it is present in the data segment register. As an example, you can see if in SI, if you have the value of 1000 and if the base address of data segment is 200, the 20-bit physical address will be calculated in such a manner that the 2000 will be multiplied with 10, so it will be 20,000. Within the 20,000 we will be adding this 1000. So the exact address location of the presence of data is 21,000. So from that location, the data will be copied to AL register, and the SA will got auto incremented by 1, that is 1001. The content in SA now becomes 1001, and the data present in 21001 location will be copied to AH, since it is a 16-bit operation. So how we differentiate is a 16-bit or 8-bit operation? You look at the destination folder. In the destination we have specified a 16-bit register, thereby you can conclude that this is a 16-bit operation. The next one is indexed addressing. So in indexed addressing, we utilize the register, index register, to specify the offset address of the data. So we have two index register, one is called source index and another one is called destination index. Simply you can say that SI register and DI register. The next one is based addressing mode. So it is also similar to that of index addressing. The only difference is here we utilize the base registers, base pointer, to point the offset data, to hold the offset address of the data. So here you can use either SP or BP or BX. So you can use a base pointer register or BX register. You also know that BX register has two purposes. One is it is used as general purpose register to store the data. The second one is it is used to hold the offset address of the data. So when you are using BX within the bracket, now BX register will be now utilized as a pointer register. The seventh one is based and indexed. So here it is similar to that of 5 and 6. Here we combine both based register and index register to find out the physical address. So the value present in BX and SA represents the offset address. It's combinedly it joined together and represents the presence of data. And the eighth one is based and indexed with the displacement. So here the memory address is calculated in such a way that we have to add the content of index register, base register, and a physical value, a displacement value will be given. It may be a 16-bit value or it may be an 8-bit value. That doesn't matter. Okay, so directly a value will also be in addition given to this base register and source index. So refer that example given, move AX comma BX plus SI plus 6. So to calculate the offset address of the data, you have to add the content of BX register, SI register, plus you have to add the physical value of 6. So these combinedly they form the offset address, and this offset address should be added to the base address of data segment. Now we will be having the 20-bit physical address generated, and from the 20-bit physical address generated, the data will be copied to AX. This is called based and indexed with a displacement. And the last one is string addressing mode. It's a special addressing mode which will have an importance when we do string operation. Generally the string operation is used to move block of data from one memory location to another location, or when we compare two data present in two different segments. So when you use string addressing mode, definitely you have to use two memory segments. One is extra segment and data segment. That is, the data from data segment will be either copied to extra segment or from extra segment to data segment. So here we have given an example, move SB. Move SB means move byte, move string byte. S stands for string, B stands for byte. So here we will be moving byte by byte data from data segment to extra segment. So while the moving happens, that offset address will be stored in SI, that is source index register and destination index register. So source index register will be utilized for mentioning the offset address for data segment, and destination index will be used to hold the offset address of extra segment register. So after moving one byte of data either from extra segment or from data segment, the content of source index register and destination index register will be get auto incremented based on the value given in direction flag. If the direction flag holds a value of 0, the content present in SI and DA will be incremented by 1. In the other hand, if the direction flag is 1, set to 1, the content present in the source index register and destination index register will be decremented by 1. So this is all about the addressing modes of 8086. So once you have the thorough knowledge of different addressing mode, it will help the programmer to efficiently write the program by addressing the data in a well-defined manner. Thank you.